limits can be taken for multivariable functions, but now it's a little bit more complicated. For example, if we want to find the limit, we write it like this now, and it goes to a certain point, and we're taking this and this into point. We want to find the limit if it exists for this, and well, if we just plug in 0, that just gives us 0 over 0, and that doesn't really take us anywhere. But we also want to go along different paths to see if it converges to a certain point. So for example, we can say along the y-axis, let x equal 0. So then we get x squared plus 0. If it's on the x-axis, then y is equal to 0. If it's on the y-axis, then x is equal to 0. So if x is equal to 0, then we have y squared over negative y squared, which is this negative 1. This is assuming that y cannot equal 0, and this would be written as f of 0 comma y. And we can also say, okay, well, what if y is equal to 0, and we're going along the x-axis? This was along the y-axis. Now we have f of x is 0, and this just becomes x squared over x squared, which is just equal to 1, assuming that x cannot equal 0. But also, because these two values are different, this limit doesn't exist, also because of that indeterminate form. For example, now we can go and say we want f of xy of xy over x squared plus y squared. And we want to find the limit of this function approaches 0, 0 of xy over x squared plus y squared. So first, let's do x is equal to 0. So then we have f of 0 comma y, and this just gives us 0 over 0 squared plus y squared. This just turns out to be 0. We can also go along, well, what if y is equal to x? Now, returning to this one, we never mind, my mistake. We are not, the answer is 0. Along y is equal to x, however, now we can plug in, okay, well, x times x over x squared plus x squared is equal to x squared over 2x squared, or just 1/2. These two values are not equal, so this limit does not exist. Sad. An example of a function that would have a limit that exists at 0, 0 would be something like this: x squared y over x squared plus y squared. And let's say we want to find a limit x, y approaches 0, 0. It looks like it says orb, but it's 0, 0. X squared y over x squared plus y squared. First, let's try along the path x is equal to 0. So that gives us 0 squared y over 0 squared plus y squared, which is just 0 over y squared, or 0. We can try along the path y is equal to 0. And this gives us x squared 0 over x squared plus 0, which is equal to 0 over x squared, or 0. And we can also go along the path y is equal to x, which would give us x squared x. And we can also write this as f of x, which is pretty cool because we're substituting the y for x right here. X squared x over x squared plus x squared, which would be x cubed over 2x squared, which is just x over 2. But remember, x is going towards 0 because this is going to that point 0, 0. So this is also equal to 0. So because all three of these are giving the same value, 0, 0, 0, we can say that the limit does exist and the limit is equal to 0. Much like in single variable, where we go from the left-hand side and the right-hand side of the function. Like, let's say we have a graph like this, and we're coming from this side, and then we're coming from that side. And if these come up to the same point, like right there, then we can say that the limit exists. Now, when we go to 3 dimensions, we have to come in from all different sorts of paths. And it can get really tricky and complicated, but this is the very basics of it.